Alrighty, good afternoon. Hopefully spring break is going well for us. We are going to take a look at some of the things we've been covering in class. So the sum and difference identities for cosine, sine, and tangent. If you want to look at the cosine family, the equation is here, the one I've bolded here in red. That's the one to really focus on. Don't worry about memorizing these, just know where to find your resources in this toolbox. The cosine one can be found on page 671, and you'll find the sine tangent family as well as the cofunction identities all on page 673. So we're going to cover 4 of the problems from tonight's homework. So the first one we're going to look at is problem number 7. And problem number 7 is finding the exact values of expressions given using the sum and difference identities. So I don't necessarily know what the cosine of 105 is. I can find it on a calculator, but I can also use those identity function things to tell me that the cosine of 105 is the same as the cosine of 60 plus 45. And I chose 60 and 45 because 60 and 45 are 2 of the values I know well on my unit circle. So the cosine of 105 is then going to equal, using our equation we used earlier, it's going to become our cosine of alpha times the cosine of beta. And then because we're adding inside, we're going to subtract in our equation because the equation stays the same, but the signs alternate. And then we're going to have the sine of alpha and the sine of beta multiplied there. And then just to keep in mind that what's going on here is we have our alpha is going to be 60 and our beta in this case is going to be our 45. Okay? So what I can see here is now I know exactly what the cosine of 60 and 45 are. So cosine of 60 is going to be 1/2. And the cosine of beta is going to be radical 2 over 2. I know that from my unit circle. Hopefully we're starting to memorize those a little bit more that we've worked with them. And then I know the sine of 60 and 45 as well. So the sine of 60 is radical 3 over 2. And the sine of beta is radical 2 over 2. So all I need to do at this point is multiply across tops. So I get the radical 2 minus our radical 6. And it's all over 4. And that right there is going to be my final answer. Okay, so that's what we're looking for. Is we're going to take some number that I may not necessarily know the values of and break it into 2 that I do. And then I can use that equation to help me out. Okay, next type of problem we're going to look at is something like number 13. Where 13, you're going to actually see there's the equation already written out for us, and we're going to recognize that our alpha, that our alpha here is 7 theta and it is repeated, and our beta is 2 theta and gets repeated. So as I see this, I can actually recognize that, oh hey, this is the cosine of alpha minus beta because of this behavior there is plus, this one needs to be our minus sign. Okay, so I can then show that this is going to equal cosine of 7 theta minus 2 theta, or I can rewrite this as the cosine of 5 theta. Okay, I don't need to actually find that value. All it wants me to do is write it as a single expression. So that's all it asks for. That's all we're going to give. So that's the next type of problem you're going to see. 23 is going to be a problem where we talk about the cofunction identity. So we recognize that sine and cosine are the same graph, basically. They're just off by 90 degrees. And so what we recognize is I can rewrite a sine function as the cosine value of 90, or pi over 2 in radians, minus whatever our t value is of our sine value. So I'm going to call this whole thing here, I'm just going to call that t. So as I write this in, both those are Yeah, so I'm going to call that t. So when I get this, I'll end up with equals our cosine value of pi over 2 minus t, which we're going to rewrite in here as pi over 6 minus theta. Okay, and then we just have to do a little bit of algebra, find a common denominator. So this is the equivalent of 3 pi over 6. So I have a common denominator. And so what I end up with here is the cosine of 3 pi over 6 minus pi over 6 is 2 pi over 6. And minus a negative theta will give me plus theta. And then my last piece is just to simplify this. So my cofunction identity tells me I can rewrite the sine of pi over 6 minus theta as pi over 3 plus theta. And these are the exact same functions. Okay, so that's what we're looking at. Sine and cosine are the same thing. I just can rewrite them with a 90-degree shift. And again, we see that down here in our cofunction identity. So that's the one we're using is right there. All right, the last thing we're going to take a look at is number 53. This one's kind of complicated, has a lot of pieces to it, and will take us a little while. So let's see what's going on. First thing I want to do here is I need to actually show that theta is the same as alpha plus beta. So this takes a little bit of geometry. When I look at this, I'm going to recognize that this is a right triangle here, and that's 90 degrees. That's alpha. So this, based on our triangle sum theorem, must be 90 minus alpha. Okay. This triangle, same idea, is going to be 90 minus beta. Okay, so I can find those values. Now I can see that this right there is going to be a straight line, and so I can actually use the equation 90 minus alpha plus theta plus 90 minus beta is going to equal 180 degrees because it's a straight line. Okay, so I see when I collect like terms, I've got 180 on both sides, so I can rewrite this as negative alpha minus beta plus theta equals 0 because I had 180 on both sides. We'll add the alpha and beta over, so we see that theta is going to equal alpha plus beta. This helps me because now when I go to do the sine of theta, we can say that this is actually just the sine of alpha plus beta, and now I can use those difference in sum identities that we've talked about earlier. Okay, so now I've got those. The last thing I want to use is our Pythagorean theorem. So I know that a squared plus b squared is going to equal rc squared, and this is going to be true because we have right triangles. It's one of our right triangle properties. And I can find the missing side length. So I don't know what this side length is, and I don't know what this side length is. But I want to find out. So using that math, I'm going to say that I've got 32 squared. Oops, sorry, 32 squared plus 24 squared is going to equal our unknown side length. Let's call it c squared, just because the sake of Pythagorean theorem. Okay, and so when I do the math on this, we will see that I want to take the square root of both sides essentially. Okay, type that into our calculator. This will actually spit out that our value for c is 40. Okay. We're going to do the same side over here, but now I'm going to do 45 squared plus 28 squared equals our c squared. We'll take the square root of both sides, and we'll see that this value is 53 over here. Okay, so I know that side length is 53. This is beneficial to me because now I can set up my trig ratios. So I need to have the sine of alpha, and I need to have the cosine of alpha. And then I need to find the sine of beta, and I want to find the cosine of beta. And so this is going to help us find our sum and difference identity stuff. So using our right triangle trigonometry, sine of alpha, here's my angle alpha, as opposite over adjacent, so it's 24 over 32. Cosine alpha is my adjacent, oh, just kidding. I made an error there, sorry. I'm going to back up. It's not over 32 because it's opposite over hypotenuse. That's why I found this value over here. So it's actually 24 over 40. Thank you for catching that. My cosine is the adjacent over hypotenuse, so now it's 32 over 40. Okay, then we'll look over here at beta, and we want sine is opposite over hypotenuse, so we get 28 over 53. And cosine of beta is our adjacent over the hypotenuse, so we end up with 45 over 53. All right, so once I have this piece, okay, what I'm going to be able to do is just plug these numbers into our equation, and we'll be able to find our values. So my computer's running a little bit slow because the screen recorder is taking a lot of power. So bear with me as this moves, and I get a brand new sheet first to work on. Okay, so there's my new sheet to work on, and here's my post-it note. All right, so I've got this piece. I still have my picture here to help us out, a little bit smaller. But all I need to do to find the sine of theta now is using our equation. So the sine of theta is the same as the sine of alpha plus beta, which we already identified. So we can use our equation of sine alpha cosine beta plus cosine alpha times sine beta. Okay, again, don't try to memorize those. Going back and use your toolbox that we've got. So now I just have to plug in these values. So I know that sine alpha is 24 over 40. And I know that cosine of beta is 45 over 53. 45 over 53. We're going to add that to our cosine of alpha, which is 32 over 40. And we're going to multiply that by our sine of beta, which is 28 over 53. Now, as you multiply this out and then add things together, we're going to see that this turns into 1976 all over 2120. And then we can simplify that fraction into 247 over 265. Okay, and so that becomes my value for sine of theta. Lots of steps. Be patient with it. You guys are capable of it. It's just kind of a long process. But now you know how to use the sum and difference identities to help you find any values for sine and cosine. Have a great break. Shoot me an email if you have any questions. Good luck.